Hello, this is Just a Jolt here, all ready to do some indices and powers in maths. Now, I've kind of learned if I stand this far away from the microphone, normally there's not too much echo, so I'm going to hope that if I just leave that over there, don't go too near it, it won't echo too much. Anyway, so let's deal with some powers indices stuff. So the way we're going to do this is we're going to use the website that I've been building for my tutees. So if I just go here, if I just go back to the home page again, this is the website. At the moment, it's at justajolt.pythonanywhere.com. That's going to change pretty shortly to infinite exam questions or something like that. But anyway, go straight to GCSE maths, and we're going to choose. We're not going to choose from geometry and measure though. We're going to choose from algebra, and we're going to go to this tab right here where it says powers and indices. Just if you're following along. Now, the first thing we're going to do is we're going to look at these basic powers and indices things. Then we're going to move on to more advanced stuff. So let's start here. So we don't want the random questions either. We want power of 0. So the first thing we're going to think about is one of the basic indices rules, and that's what you do with the power of 0. So what we've got here is 87 to the power of 0. And the answer to this question is going to be really, really simple, because basically all the time there is never an occasion. Just going to go to the live dashboard here so I can see if there's anyone on. Fantastic. So basically, anything to the power of 0 is going to be to the power. The answer to that is simply going to be 1. That is always going to be the answer to that. Anything to the power of 0 to the power is going to be 1. So x to the power of 0, the answer is 1. 1 to the power of 0, the answer is 1. 2 to the power of 0, the answer is always 1. And this is kind of the first rule that we're going to go through. Now, the reason for that, if you just Google any number to the power of 0, you'll get an amazing YouTube video up, which isn't mine, but it's absolutely incredible, which kind of explains the reason why this is. Now, at this point, we're going to go back to my website again. And you can see here that we should get the answer of 1 here. Let's generate another one of these. So now 90 to the power of 0, the answer is 1. You can just see it's always going to be 1. The answer to this question is always 1. So anyway, let's get rid of that, go back to that page. That's quite easy. The next rule I want to look at is what happens when you do anything to the power of 1. So let's just take, for example, rather than that to the power of 1, let's just change all of these now. Let's just have all of these to the power of 1. And I'm going to use this example at the top here, 87 to the power of 1. Well, let's just think about this for just a second. Let's think about this for a second. What do powers actually mean? Well, let's say that I were to take x times x. Now, a simpler way to write that would be x squared. Am I right? Because you've got x times x, and that's x squared, all right? Now, let's take a number that we can actually evaluate. How about 2 times 2? That equals 2 squared, which the answer to that is actually going to be 4, because 2 times 2 equals 4. Now, what happens if you take that same 2 and you do it to the power of 1? Well, the power of 1 basically just means 2 by itself, which kind of equals 2. And this is a pattern that we've got. If we have, let's change this from being x to being 4 now. Let's say we do 4 times 4 is obviously going to be 4 squared, which is going to be 16. 4 times 4. Well, what happens if we say that this is instead 4 to the power of 1? Well, if it's 4 to the power of 1 here, with a 1, then obviously, clearly, that's just going to be kind of 4 by itself, isn't it? So 4 to the power of 1 just equals 4, which equals 4. There's no real change there. So let's take a look at this. 87 to the power of 1, in that case, is not going to be 87 times 87. It's just going to be 87. So 87 to the power of 1 then is just going to be 87. X to the power of 1 is going to be x. 1 to the power of 1 is going to be 1. 2 to the power of 1 is going to be 2. So let's go back to my website quickly and let's have a look at what happens if you have something to the power of 1. 56 to the power of 1, 56. Move that back there. Let's have z to the power of 1 is just going to be z. So any number to the power of 1 is just going to be whatever that number is. 11 to the power of 1 is just 11. 4 to the power of 1 is 4. J to the power of 1 is j. So you get the idea. So to the power of 0, the answer is always 1. All right? Power of 0, the answer is 1. The power of 1, the answer is always going to be just whatever that number initially was. So again, let's get rid of this. Now let's have a look at something else. So now we've got 1 the power of 49. And so our next rule, I just going to write on the board here to make a note of what we've done so far. The first thing we did, looked at the power of 0. Power of 0, we've looked at that. Power of 1, we've looked at that. Now, what happens if we have 1 to the power of anything? All right, 1 to the power of anything. Let's just think about this for a second. What happens if you have 1 to the power of, say, 3? So 1 to the power of 3, what does that mean? 1 to the power of 3 means 1 times 1 times 1. Okay, that's what it means. So let's calculate that. Let's work it out. 1 times 1, that's 1 times 1, 1. Do you guys see what I'm saying here? Well, maybe if we use a bigger number, power of 5 times 1 times 1, it doesn't matter how many times you multiply 1 by 1, the answer is always going to be 1. And so if I wanted to, I could write some stupid number up here. I could have 1 to the power of, I don't know, 86. And even if I were to write all of these 1s out 86 times, the answer to that is still going to be 1. It's never ever going to change. Honestly, even if I write like 365 million, bazillion, jillion, some kind of number that doesn't even exist, the answer to that is still going to be 1. So 1 to the power of x, 1 to the power of anything is always going to be 1. Now let's just go back to my website here and look. So you got the answer 1 to the power of 49. If you can visualize this, and if you can kind of imagine 49 1 times itself, the answer is still going to be 1 there. All right, honestly it is. The answer is still going to be 1. There it is, 1, 1. The answer is always going to be 1. 1 to the power of 14, 1. So anyway, you get the idea. That's kind of our third rule, all right? And we're going to need all these rules when we deal with powers. So anyway, let's now think about what happens when you multiply powers together. All right, so we're now going to multiply powers. I'm just going to write multiply powers. Going to run out of space here. Going to need a bigger board, definitely. For multiplying powers. So let's have a look at this. Let's just take x power of 4 plus x. Whoops, now we're multiplying these, aren't we? Times x to the power of 2. And what I'm going to do is actually write this out so we can see what's going on. So this is equal to x times x times x times x, several x's. There's my first one. There's x to the power of 4 times x, which is x to the power of 2. So there's my x to the power of 4 right there. And there's my x to the power of 2 right there. Now, what we've effectively got when we do this is actually x to the power of the number of x's in this total kind of sum here, which is 1, 2, 3, 4, 5, 6. So this is actually equal to, what am I even doing? X to the power of 6. All right, that's what we've got, x to the power of 6. Now, we can do this every time if we want to. We can write it all out every single time, calculate this, or we can simply add these two numbers to get our 6 as well. So now let's go and have a look at an example from the website. So multiplying powers together. And the example that we've got up there is 18 to the power of, what does it even say, 3. 18 to the power of 3 times 18 to the power of 7 times 18 to the power of 8. Now, I can tell you right now that I am not going to go writing all of these out. I'm just not, because that's like 7, writing 18 out 7 times, 8 times. Mathematicians are lazy. Physicists are lazy. Everybody in all of these kind of STEM subjects are as lazy as possible. And so what are we going to do with this? How are we going to work this out? Well, do you remember before, if I were to write all of these out, I'd end up with 3 18s, 7 18s, and 8 18s, all times each other. But rather than doing that, I can just add these numbers up now. So 3 plus 7 plus 8 is 18. So the answer is going to be 18 to the power of 18, which is a bizarre coincidence. And if I wanted to, I could run that through a calculator and I could actually calculate this. So let's go back to the website now and have a little look and see if that's the answer we get. 18 to the power of 18. Like I say, you could run that through a calculator if you really wanted to. Let's have another one. Oh, we've got n's now. Look at that. So we've got n power of 9 times n to the power of 1 times n to the power of 6. All right, fair enough. Let's see what this does. So again, exactly the same as before. We've got this 9 plus 1 plus 6. We should be able to work this out super quickly now. It's going to be n to the power of 16. You couldn't work this out unless you know what n is. If you know what n is, you can work that out. We don't, so we've got to deal with it. Deal with it. All right, so anyway, there we go. So n to the power of 16, you get the idea. Let's do one more together. So this time we got, I'm not even going to write this one out. So you got b to the power of 9 times b to the power of 1 times b to the power of 3. Well, if we just do 9 plus 1 plus 3 is 13. The answer to that is b to the power of 13. And there's our answer. So now let's move on to the next one where we've got dividing powers. Now, dividing is the opposite of multiplying. It's the opposite of multiplying. So how about we look at this? Let's have an example. If dividing is the opposite of multiplying, when we were adding the powers for multiplying, do you think it's logical that we'll be subtracting the powers for multiplying? I do, and I'm not logical at all. So let's go with x again. X to the power of 7 divided by x to the power of 3. Now, let's look at this in a slightly different way, shall we? So let's have x times x times x times x. This is why we don't write them all out. It is boring as heck. Times x, 1, 2, 3, 4, 5, 6. Oh my goodness. Times x divided by x times x times x. Now, if you know anything about that's x, believe that is definitely an x. Now, if you know anything about kind of dividing things and cancelling things out, then you'll be able to just look at this and you'll be able to say, well, we can cancel some of these out. We can cancel that out, and we can cancel that out. And that means we've just left with x to the power of 1, 2, 3, 4 there. So the answer would be x to the power of 4. And that's absolutely correct. The thing is, we don't need to do this. We don't need to do this every time because we just know that 7 minus 3 is 4. And that's just what you do when you're dividing powers. And that's why it works. Okay? I'm not going to do another example like that because you've kind of seen that now and I want to shift on. But let's take a look at an example from the website. So I'm going to go back here, dividing powers now, and blimey, oh, right, this is crazy. And this is the kind of thing that I don't want to be having to work out the other way. So I'm going to do it the easy way using the tools we've got. Divided by p to the power of 7 divided by p to the power of 9 equals. Whew, okay, let's see if we can work this out then. So we've got 23. So using this rule up here, we've got 23 minus 7 minus 9. I'm actually going to add this 7 and this 9 to make my life easier. It's 16. So 23 minus 16, I believe is going to be 7. I think that 23 minus 16 is going to be 7. That's going to be p to the power of 7. Let me just check this. So 23 minus 7 is going to be, yeah, I'm happy with that. P is 7. So let's have a look at the answers. Check the answer here. There we go. We've got p to the power of 7. Let's do another one. So now we've got 83. And again, there's nothing stopping you. If you've actually got a number there, you can work it out. P is not a number that we can work out, so let's not bother. Let's have 83 to the power of 9 divided by 83 to the power of 1. That's definitely a 9 there. Divided by 83 to the power of 4. So again, we can do this very, very quickly now. 83 to the power of 9 divided by 83 to the power of 1, 83 to the power of 4. 9 minus 1 minus 4 is going to be 83 to the power of 4. And all I've done there is 9 minus 1 minus 4 leaves 4. So let's check that quickly on the website just to make sure. And you've got 83 to the power of 4. All right. So far we've been through multiplying powers. We've been through dividing powers. And as it stands, these are all kind of skills so far which are fairly low level in terms of the grade they're worth. Questions like, if you can do questions like this, you're probably at like a level 3 or something, level 3, 4. If eventually I'm going to have that reflected on the website as well. I don't yet, but that's level 3, level 4-ish. Now, maybe just level 3 to be fair, because it's quite easy. If you want to do some harder stuff, and this is now getting up towards level 5-y sort of stuff, then really you want to be looking at the advanced powers and indices stuff, and that gets a bit tricky. That gets a bit dicey. So this is where it gets interesting. So, what's going on here? So raising a power to another power. This is a bad example to start off with, so we're going to have another one. That's better. I prefer that one. I'm going to, there we go. So let's have, write this out. So we've got j power of 6 times all of that to the power of 4. Blimey O'Reilly, now what exactly is going on here? So let's take a look. We've got j to the power of 6 and all of that in those brackets to the power of 4. So whereas with multiplying powers, you just kind of add them together. If you're raising one power to another power, then you have to multiply both powers together. Now, the reason that you're doing this, oh man, I wish I had an easier example. I'm going to write myself out an easier example. Let's have x to the power of 2, the power of 2. So I want you to imagine this. So you've got x to the power of 2. So effectively, we could just say that's 2. So that's x times x. And then another, the power of 2, x times x. Right, so you see that? And what we end up with here is we actually end up with 4 x's in our brackets. Let's pretend it was something a bit higher. Let's say it was x to the power of 3 here instead, in which case we'd end up with x times x in brackets, and another x times x, and then because it's to the power of 3, another x times x. And you end up with 6 now. And so the pattern is you multiply the two powers together. So you multiply the power in the brackets by the power outside the brackets to get your answer. So let's now go back to that example there. So you've got j to the power of 6 to the power of 4. Now I could go ahead and write out this j to the power of 6 4 times and count up the number of j's I've got to work out my power, but I am not going to do that. Instead, I'm just going to multiply that by that, and I'm going to say that the answer is j to the power of 24, because 6 times 4 is 24. I'm going to go back here, and that is in fact my answer. So let's have another one, and let's see what this is. We've now got 31 to the power of 1 times 7. Well, that's easy. That's just going to be 31 to the power of 7. Let's have another one. We got that's not a 0. That's an O. The power of 7, power of 1, that's also going to be O to the power of 7. That one's more beefy. Let's use that one. 53 to the power of 9 to the power of 9. So 53 to the power of 9 to the power of 9. Well, again, we've got that same situation. So we've got 53, and if I wanted to, I could write 53 times 53 times 53 times 53 times 53 to the power of 9 9 times. Not going to do that. Instead, I can just go 9 times 9 equals 81, and I could actually go ahead and work that out on a calculator, which would be some kind of stupidly big number. Not going to do that. So you've got 53, sorry, to the power of 81, because 9 times 9. Okay, next rule that we are going to cover here is, what have I got here? Raising 2 powers to a power? Okay, raising 2 powers to a power. This is basically an extension of what we were doing before, but we'll go ahead and do that. It's a combination of multiplying powers and raising powers to a power. So you've got v to the power of 6 times v to the power of 9, and all of that to the power of 5. So we've actually got 2 steps that we need to go through right here to do this. So you've got v to the power of 6 times v to the power of 9, all right? And we already know that we can just add those together. So let's go ahead and add those together, which gives us v to the power of 15, power of 5, all right? Because we've got power of 5 there. So we've added these together using the multiplying rule, and now we can go ahead and we can use that kind of raising a power to the power rule. 15 times 5 is going to be 75. I just kind of know that. V to the power of 75. So let's go back here and check the answer. And if I've done my programming correctly, that is in fact the answer, which makes me super, super happy. Let's have one more of these before we move on. Is that exactly the same? No, it's slightly different. That's fine. We'll work with that. We'll work with that. That's what we've got. Okay. So I'm going to write this out again. So you got q to the power of 5 times q to the power of 9 this time. All of that raised to the power of 7. And again, I'm first of all going to apply my multiplying powers rules for this kind of bit in the middle, for this bit in the bracket. And I'm going to say q to the power of 14, because 5 plus 9, all that to the power of 7. And then you've got 14 times 7. I'm going to have to just do it like this, because I can't do that in my head. Probably could, to be fair, but I'm not going to, in case I get that wrong. So I'm going to do the way that I know I'm going to be safe. 28, 7 times that, going to be 98. So we should have, just watch me fail at this now. The answer to this should be q to the power of 98, which it is. That makes me so happy. Look at that. Jolt's got skills. Alrighty then. So now we're going to move on to something else, which is raising powers to a fraction. So raising fractions by a power. Raising fractions by a power. Now this is where things get, again, we're now quite firmly in level kind of 5, 6 kind of stuff, because these are more difficult sort of concepts. So when we're talking about raising fractions by a power, it seems like quite a complicated thing, but it's really not. So here's how you go about doing that. So let's say you had something like this where it says evaluate 4 over 7 all raised to the power of 2. Now you'll quite often see these in brackets. You might not do, but if you do see them in brackets, it's exactly the same thing. I've chosen to use brackets, otherwise on the screen it looks like you've got 7 to the power of 2, 4 over 7 to the power of 2. So I chose to use brackets to make that easier to see. So in this situation, what you've got to understand is that we want to kind of keep the same kind of proportionality here between the top and the bottom. So effectively what we're doing, the rule is that you're simply going to raise each of these numbers to that power. So 4 to the power of 2 is 16, over 7 to the power of 2 is 49. And if it's possible to cancel that down, you can go ahead and cancel that down, which in this case you can't. I've just realized I did all that off screen, which is rubbish. So you're raising this power to the power of 2, then that power to the power of 2, and you're ending up with 16 over 49. And here's your answer now. So 16 over 49, just like that. So let's have another one of those, I think. So we're generating another one now. So we've now got 9 divided by 2. So 9 over, is that 9 over 2 to the power of 3? Yeah, 9 over 2 to the power of 3. Quick changes up there. So exactly the same working out as before. 9 over 2 to the power of 3. Power of 9 to the power of 3. 81, I should be able to work that out, to be fair. So let's just do, squared is 81 times 9. So times 9 is 9. 8 times 9 is 72. So the answer should be 972 over 2 to the power of 3 is 8. So we should have 929, sorry. 729, the power, 729 over 8 should be the answer to that anyway. Let's go back here, and that's exactly what we've got. That's pretty simple too, so let's move on to our next rule. So raising fractions including a letter by a power. Okay, so let's write that out. So u over u, all of that to the power of 1. All of that to the power of 1. Well, in the case of letters, it's actually pretty simple. We're going to keep the fraction there, and we're going to say u to the power of 1 over u to the power of 1. And actually, in both cases, we know that u to the power of 1 is going to be 1, but nevertheless, I've kind of included it there to make the point. Again, it's the same. Let's have a look at this one here. So I'm going to write this one out. So we got x over d to the power of 2. Here we go. We've got that written out there. And the rule is again, it's very, very simple. It's the same rule as before. So you've got, you're going to end up with x squared over d squared. All right, and we're just following that rule. So n squared over s squared is going to be the answer. U to the power of 1 over z to the power of 1. Is that, I'm just kind of wondering here, are 1, 2, and 3, are they the only powers I've included in this? I really need to change that around. Programming, guys, sometimes you miss some stuff. Sometimes there's a bit of oversight there. Right, anyway, let's move on to the next rule, negative powers. So when you're dealing with negative powers, basically what you do is, let's just find an interesting one, shall we? Find an interesting one. Yeah, that's a bit of an interesting one there. When you're dealing with negative powers, get rid of this. What you're going to be doing is effectively, you're effectively turning what you've got into a fraction. You're effectively turning what you've got into a fraction. So there's your answer there. And how on earth did we reach that? How on earth did we reach that? Well, whenever you're dealing with negative powers, then your answer is going to be 1 over something. So your denominator is always going to be 1. What number do you put on the bottom? Well, 5 to the power of 4 is 625. 625. So the power of this number becomes the numerator of that fraction. Okay, and the reason is because you end up with a fraction that is 1 divided by the power of the number that you've negatived, if you like. So let's have a look at another example of that. So you've got 7 to the power of negative 3. So let's write that up there. So you've got 7 to the power of negative 3. What's the answer to this going to be? Well, because we're dealing with a negative power, we know the answer is going to be 1 over something. 1 over 7 to the power of 3. 1, 7, 49 times 7. Man, I should know this off by heart, but I really don't. 7 to 147. I've done that wrong. There we go. Let's do it. Let's correct myself. There we go. There you go. 49 to the power of 7. I could just do this on Python or something. It'd make my life a lot easier. Let's just do that actually. Make that quicker. 7 times 49 is 343, which means that my answer should be 1 over 343. There we go, and we'll just check that quickly. There you go, 1 over 343. Now, we've got 2 more of these to go, so we'll do 2 more of these, then we'll call it a day for today. Next one is negative powers with letters. And this is actually really, really simple. So you've got t to the power of negative 9. The way you deal with this they're even easier than these, really, because what you end up with is that same fraction, but you have over t to the power of 9. All right, and that's how you do that. It is that simple. So your answer there, 1 over t to the power of 9. Let's have another one. So you've got j, the power of -5. And if you just watch what I do again, it's that simple. 1 over j, the power of 5. And to be fair, doing this kind of illustrates that rule. So let's do one together quickly. So you've got p to the power of -8. Well, the answer is going to be 1 over p to the power of 8. And there it is. All right. And the last one then, the last one is fractional powers. And this is interesting because a fractional power is effectively a square root. So 64 to the power of half, you're effectively looking for the square root of the value here. And so the answer, of course, to this is going to be 8. And So as long as your kind of fraction is 1 over something, then you know that you're looking for a square root here, or if it's 1 over 3, it's going to be a cube root. Let's see what the next one is. It is a 1 over 3. So in this case, we're simply looking for a cube root. All right, so cube root of that, I couldn't tell you, but if we were to do it on a calculator, we'd work it out. There you go, it's 6. So 6 times 6 times 6 equals that. Let's have one more. So we've got 125. Cube root of 125 is 5. The answer is 5. Okay, so what have we been through today? If I go back to the website, you can actually see everything we've been through. We've quickly flicked through all of these different rules for dealing with powers and indices, including some advanced ones. These ones are kind of level 3. These ones are a little bit more advanced. These ones we're kind of champing at the bit of kind of level 5 and 6-ish. Now, next time we're going to be looking at surds, and surds get a little bit crazy. I'll have to update this with the actual, with the different actual categories of the different surd questions I've got. But the surd questions get a little bit crazier, and when you start dealing with the surd rules, then you're talking about your level 7s getting up towards level 8s with some of the more complicated surd rules. Anyway, thanks very much for watching. This has been Just a Jolt teaching you algebra, and hasn't it been delightful? And this is Just a Jolt signing off. Clickety, 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 clackety.